Hi, let's talk about exponential and logarithmic functions. First of all, we should know what is the relation between these functions. Exponential function you can define as fx is equal to a raised to power x. And logarithmic function we can define as fx is equal to log of some number here with the same base a. So basically what happens here is, this is your answer of the exponential function. When you define a log function, this is log of that number y with the base a, and your answer should be x. This is how we can understand this function. So I will write here f inverse x, and I can give another name to this function here, gx. It will be easy to understand if you write it in number is equal to, when you do a exponent to some base. For example, 2 raised to power 3 gives you number 8. And when you write the logarithmic function, log of that number which you had here in this expression with the same base should be equal to the exponent. That means log of number 8 with the base 2, answer should be 3. And you can verify this with the logarithmic exponent formula. This expression is actually equal to 2 cube with the base 2, and this exponent can come on the front. You get 3 times log of 2 with the base 2, and log with its own base is equal to 1. So 3 times 1, the answer is 3. That means we get from this information, you can notice they are inverse functions. Let's look at the proof of this, that they actually are inverse of each other. Let's look at the x values. If you consider some values here, -1, 0, 1, 2, or 3, your fx function will have the values 2 raised to power -1, which will be 1/2 equal to 0.5. 2 raised to power 0 is 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. Now, this is the range of function fx. And this was the domain. These are some numbers from the domain. This is not actual domain. I will write down here what is the domain of this function later after. Let me describe this. We will highlight the points here for the graph and consider the y values here, the positive y values. And then you have some negative y values here below the x-axis. Let's graph this function. For x equal to -1, your fx is 0.5. That point should be here, right in the middle. And if you go with one more negative point, for example, say -2, that will be 1/4, which will be 0.25. And that point will be more close to the axis. At x equal to 0, y value is 1. X equal to 1, y value is 2. X equal to 2, y value is 4. And x equal to 3, that value will be somewhere here, which is 8. And the graph will look like this. And this is the graph of the exponential function 2 raised to power x. And now, since I told you this is the inverse function, which is log, let's verify. Because if two functions are inverse function of each other, their graph should be mirror image between mirror image through the line which is making 45-degree angle with x-axis, and their domain and range they flip. So now if I make this range of fx as the domain of the g function, which is my log function right now, let's find what will be the answer which we get as range of the g function. When you find log of 0.5 with the base 2 or log of 1 with the base 2, so you can check these values. You can use a calculator for this, or I can use a simple formula, exponent formula here. This is 2, -1, 0.5. I can write 5 divided by 10, which could be written like this, and the exponent comes on the front, and log of 2 with the base 2 is always 1. Log of 1 is 0. Why? Because you can write it log of 2 raised to power 0 with the base 2. By using the same formula, we get these values. And you can match these values on the left. This was actually the domain of your function fx. This number should be -1, -2, sorry. Let's graph the other function now, which is my log function. When x is equal to 0.5, the y value is -1. And I can pick this value from the bottom. 0.25 value is -2. So we can go a little more down here. 0.2 is this value. At number 1, the value is 0. At number 2, the value is 1. At number 4, the value is 2. So we are here. We can graph this function. This is log x with the base 2. And you can notice that these two graphs are mirror image through the line which is making 45-degree angle with the x-axis. So that is evidence that they are inverse functions. And you can also notice from here the domain of f function, which is your exponent a raised to power x, which was 2 raised to power x in this case. You can consider any value of x from here, no problem. But the answers you are getting here are your y values. They are never 0, but they are positive. So your domain is -infinity to infinity for the exponential function, but the range of that function is 0 to infinity. Whereas the inverse function, which is your log function, the domain is never 0. You can never find the log of a negative number or 0. Domain of gx function here, which is inverse of fx, is 0 to infinity. And the range of gx is -infinity to infinity, which is another evidence of the inverse functions, that their domain and range they get exchanged. And one more point you can notice here. For the fx function, y-intercept is 0, 1, whereas x-axis works as its asymptote, is your x-axis, and its equation is y equal to 0. Y equal to 0 works as asymptote to the exponential functions. For gx function, x-intercept is 1, 0, whereas your y-axis, I can donate it with the blue color dotted line here. It's not visible nicely. Yes, I can extend it a little bit. Y-axis, the equation of that axis is denoted by x equal to 0. X equal to 0 works as asymptote for the function gx. These are some important points which you notice when we discuss about the exponential function and the logarithmic function. And this is true for if I change the base from 2 to 3, 4, and 5. And in my next video, I will teach you how to find the domain of the logarithmic functions if the value changes. It's not log of x, but it is something else. For example, log of 2x plus 1 with some base. For that explanation, watch the next video.